Hello everyone. Okay, so in this video we are starting our little journey on probability, and we're going to be looking at counting and arrangements. So we're going to be looking at, first of all, the fundamental principle of counting. So this is one of the more basic rules of probability, but what is it? So the fundamental principle of counting states, so I'm looking at this definition here. Fundamental principle of counting states that if one event has m possible outcomes and a second event has n possible outcomes, then the total possible number of outcomes is m times n. So you must learn this off. So this is something in an exam they could ask you to state and then give an example of. But let's see it in action. So look, this is a worked example here. So John is going to a festival over the weekend. Each outfit he will wear will consist of a pair of jeans, a shirt, a jumper, and a pair of shoes. He has packed, not really festival attire, is it? Anyway, he has packed 3 pairs of jeans, 4 shirts, 2 jumpers, 3 pairs of shoes. Write down 2 examples of different outfits John could wear. So, an example of an outfit John could wear. He could wear blue jeans, white shirt, to quote Lana Del Rey there. You can wear blue jeans, white shirt. You can wear a black jumper, and then he can wear boots. Right? So that is a combination of outfits. But now we're going to ask ourselves, how many possible outfits does he have? So if you look here for the pair of jeans, he has 3 options for the jeans. So I'm going to multiply that by the number of options for shirts, which is 4. Multiply it up by the number of jumpers, which is 2. Multiply by the number of shoes, which is 3. 2 times 3 is 6. 6 times 4 is 24. 24 times 3 is 72. Wow, ate that. Right. So he has 72 possible outfits. So, let's look at some exam papers now. So this is from the 2020 paper 2 last year. So Ben has to choose 3 subjects to study. He must pick 1 subject from each of these groups. So Group A has 3 subjects, so he must pick French, Spanish, Spanish, or German. He has to choose between biology, physics, chemistry, and business. And he also, finally in Group C, has to choose art, accounting, history, geography, or economics. So how many choices of the 3 subjects could Ben make? Well, again, like fundamental principle of counting, right? So for FPC, fundamental principle of counting, he has 3 options for the first one, 4 options for the second one, 5 options for the last one. That is going to be 60 possible combinations. So the school is going to add 1 extra subject to one of these groups, A, B, or C. Which group should the extra subject be added to in order to make the number of different choices of 3 subjects that Ben can make as large as possible? So I want to know, right, if I add which one here is going to give me the bigger number. So if I add 1 in Group A, what will I get? So if I add 1 in Group A, I'm going to have 4 options in Group A now. Then it's 4 in Group B, and then, oops, I just put all this down. You get back up there. Right. And then we have 5 for the last. That is 80. Okay, that's option 1. What if I add it to B? If I add it to B, well, I have 3 options for the first subject. I have 4 options for the second one. And I have 5 I'm going to have 5 options for Group B. So 3 times 5 times 5 is 75. Okay, that's the last one here. So if I add it now to Group C, 3 times 4 times 1, 2, 3, 4, 5. So add 1 more, which is 6. So 3 times 4 times 6, which is 72 outcomes. So obviously it's the one where I added to A, right? So add subject to A. There you go. That gives me the largest amount of combinations there. Let's look at another one. This is from the 2020 paper. So we see probability fundamental accounting comes up a fair bit. So this is from the 2020 paper. So a restaurant is offering a 3-course meal consisting of 1 starter, 1 main, 1 dessert. And there are 4 starters, 6 different main courses, and 8 different desserts. How many 3-course meal combinations are available? Well, for starters, he has 4. He has 4 options for starters. How many options does he have for mains? He has 6 options for main. How many options does he have for dessert? He has 8 options for dessert. So 4 times 6 times 8. He has in total 192 possible combinations there. So let's look at part 2. When Jack visits the restaurant, he discovers, so part 2 over here. So when Jack visits the restaurant, he discovers that the restaurant still has 4 starters and 6 main courses available, but is sold out of some desserts. Jack now has 120 different 3-course meal options. How many desserts are still available for Jack? So we don't know how many desserts he's sold out of, but we know he still has 4 options for starters. He still has 6 options for mains. We don't know how many options he has for desserts, so I'm just going to call that D. Right? Actually, I'm not going to call it D. I'm going to call it going to call it M. Right? M for dessert. So M is equal to number of desserts. That is going to equal 120. So 4 times 6 is 24. Times M is 24. M is equal to 120. 120 divided by 24. Gonna give me, so divide by 24. We're gonna get M is equal to 5. So there are 5 possible desserts. Now, so state the fundamental principle of counting. So again, 2014 paper 2. So they asked us to state the fundamental principle of counting. Again, that's just my definition up at the top of the video. So when I have M possible number of outcomes and N possible outcomes for another object, together I have M times N. So how many ways are there to arrange 5 distinct objects in a row? So this is something to do with arrangements, which I'm going to cover now in one moment. Actually, you know what? I'm going to skip this one because that is arrangements, and we're going to go right into arrangements right now. So, arrangements. Before we do arrangements, you need to know what a factorial is. So this little guy here with the exclamation point, that's a factorial. So that is some new notation for leaving cert. So a factorial, right, just means if I have 5 factorial, that just means 5 times 4 times 3 times 2 times 1. Right, if I have like 10 factorial, that's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right, so you're multiplying every number less than it together down all the way to 1. So n factorial, right? N factorial is equal to n times n minus 1 times n minus 2 down to 1. So that's going to be important now for arrangements to know what we're doing. So let's look at my worked example 3.1 here. How many ways are there to rearrange the letters of the word Friday? It's Friday. If each letter is used no more than once in the arrangement. So I could only use each letter once, and each letter has to be used. Well, let me just kind of break it down like this. Always help to kind of draw out boxes. So I have 6 spaces in the word Friday. In my first space, I'm going to have 6 options, because it could be F or I, D, A, Y, right? But once one of them is chosen, I'm going to have 1 less option. So my second space is going to be 5. And then my third space is going to be 4, 3, 2, and then finally at the end, every other letter is used, so I'm only going to have 1 option. So that is going to be 6 factorial, which is 720. Right? And then if you want to know how to do the factorial, in your calculator, what we do is, I can make this bigger, gorge. So we're looking for the factorial, and factorial is above the x to the power of x minus 1. This little guy here, see how it's in the yellow here, we're looking for the exclamation point. So I'm going to type in 6, and then I'm going to click shift, because that allows me to hit all the yellow buttons in here. I'm going to click that, 6 factorial, click equals 720. So that does it for me. So there's 720 possible ways you could rearrange the word Friday with only using each letter once. But now we're going to be looking at arrangements with restrictions. So this is why the box method comes really important. How many of the arrangements begin with the letter D and end in a vowel? So begin with letter D, end in a vowel. So I still have 6 blocks. 1, 2, 3, 4, 5, 6. So my first one has to begin with D, and my last one has to begin with A or I. So my first one here, D. How many Ds do I have? I only have 1 D. So I only have 1 option there. Then I'm going to have 5 options here because it's 5 letters left. Then 4 options. Then 3 options. 2 options. Now I'm at the last. Letter here. But we notice here A or I. Right. Right. Oh, sorry, to reiterate there, sorry. So I have A or I here at the bottom here. So I have 2 options of A or I. Ignore what I just said. I'm not asked to start over again. I have A or I. So I have 2 options for my last number. So I'm already using D in the first one. I'm already using a vowel here. So that's 2 possible objects already taken. So therefore, I only have 4 options for my second one. So for example, if I have Friday, right, and say if I use A and D, I only now have 4 options to choose with. So then I'm going to have 3 options to choose with, 2, then 1. So multiply all of them together. 1 times 4 times 3 times 2 times 1 times 2. I'm going to have 1 times 4 times 3 times 2 times 1 times 2. 48 arrangements. Now here, how many of the arrangements have the letters A and Y together? So now you could be asked about arrangements that have 2 letters or objects stuck together. So it's going to look like this. So I'm looking for A and Y. So F or I, D, A, Y. So I have F or I, D, A, Y. So if you're looking here, like if you look here, this A, Y, that is like its own block, right? But you have to recall, you have to remember, I could also write this as right. It didn't specify what order we need things in. So it could be AY or it could be YA. So what I need to do is first I need to now find my probability here. So I'm going to have 5 options. I'm going to have 5 options for my first block. So I'll just rub this out. Ding, 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 ding. I have 5 options there because I have 5 blocks. 1, 2, 3, 4, 5. I have 5 blocks that A and Y need to be together. So I have 5 options for the first one, then 4 times 3 times 2 times 1, right? And then finally, I multiply all of that by 2. And this 2 corresponds to this little last block here because I could have YA. So that's why I'm multiplying it by 2 because I have AY or YA. So I'm going to multiply all that in. 5 factorial is 120. And then times 2 is going to be 2 partially. So I'm going to have 240 arrangements. let's look at some questions. This is from the 2018 paper. Find the number of different arrangements that can be made using all the letters of the word rainbow. Each letter is only used once. So 1, 2, 3, 4, 5, 6, 7. The 7 letters in the word rainbow. So I have 7 options for the first space, then 6, then 5, then 4, then 3, then 2, then 1, which is 7 factorial. And then 7 factorial is equal to 5040. Find the number of different 3-letter arrangements that can be made using the letters of the word rainbow. Each letter is used at most once. So now we're just looking for how many 3-letter words we could make from the word rainbow. So now I'm only looking for 3 spaces. So a 3-letter word. So my first space here, I'm going to have 7 options. My second space, I'm going to have 6 options. And then in my third space, I'm going to have 5 options. So I can't use a letter more than once. So 7 times 6 times 5 is 210. So I have 210 possible 3-letter words from the word rainbow. Let's look at this one now. This is from the 2015 Leaving Cert level paper. So a bank issues a unique 6-digit password to each of its online customers. The password may contain any of the numbers 0 to 9 in any position, and the numbers may be repeated. For example, the following is a valid password. So we have 10 digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, no, 1. No, we have 0, 1, 2. Okay, digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have here 10 digits, right? Then what I do here is it says this bank is using a unique 6-digit passcode to each of its online codes, and then the password may use any number from 1 to 9, and it may be repeated. So I can use the same code again. So for the first block, so we have 6 numbers in my pin. So I could have 10 options for the first one, because it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to have 10 options for the second one, because they're allowed to be repeated. And then I'm going to have 10 options again, 10 options again, 10 options again, 10 options again. Times them together. That is 10 to the power of 6, which is a really big number. 1, 2, 3, 4, 5, 6. Whatever that is. 1 million. So we have 1 million possible passwords there. How many different passwords do not contain any 0? So now I want passwords that don't contain 0. Here's my restriction. So I have a 6-digit password. 1, 2, 3, 4, 5, 6. Now, I am not using 0. I am not using 0. So now I only have 1, 2, 3, 4, 5, 6, 7, 8, 9 options. And again, it says it can be repeated. So I have 9 options for the first, 9 options for the second, third, fourth, fifth, sixth. 1, 2, 3, 4, 5. Which is going to be 9 times 9 times 9 times 9 times 9 times 9. 1, 2, 3. 9 to the power of 6. Which is 531441. So 531,441. That's how many passwords we have with no 0 in them. So then finally part 2 here. One password is selected at random from all the possible passwords. What is the probability that the password contains at least 1 0? So I want to know how many passwords contain at least 1 0. So this is how many passwords contain no 0. So therefore, it will be 1 million minus 531441. That is going to be equal to 1, 1, 2, 3, 1, 8, 9, 881 468 559. Right, so that is how many passwords contain a 0. So that's how many passwords contain a 0. So the probability of at least 1 0 is going to be 468 559 all over 1 2 3 4 5 6. So I have 1,000,000 possible passwords. I have 468,509 of them contain a 0. 1 2 3 4 8. So the probability is 0.468559, which is equal to, it didn't ask me to round or anything, so I'm just going to round it to like 0.47 or 47%. So there's 47% chance of getting that wrong. Let me just double check my figures here. Surprise, not a nice little number. Yeah, 468, yeah. Then 1 10 to the power 6. Yeah, okay, I'm right. There you go. Right, then let's look at this one here. Part C. John is issued with one such password from the bank. Each time John wants to access his account online, the bank website requires him to input 3 of his passwords digits into the box provided. For example, he may be asked for the 2nd, 4th, and 5th digit as shown below. In how many different ways can the bank select the 3 required boxes? So he is only going to ever be asked 3 of his digits, right? And it's not going to be repeated, so it's not going to be asked him to say his 2nd digit 3 times. So he's going to be asked, he's going to be prompted on his screen, enter your 1st, 2nd, and 5th digit, or 2nd, 4th, and 6th, etc. So how many options for digits I have here for my first one? Well, I have 6 options for digits for the first one. Then I'm going to have 5 options for digits because I'm not repeating. So once that one's used up, I only have 5 options for this one. And then I have 4 options for digits. That's my answer. So 6 times 5 times 4, 6 times 5 times 4. That's going to be 120. Alright, so 120 possible combinations or arrangements. Right, and that's this video donezo. I think it is, and yeah, so hopefully it was some help, and I'll catch you guys later. Bye bye.